Practically speaking, converting from strings to other values is really just the same as converting from other values to strings. Just as there was a string conversion function that would take as input some value and return the string representation of that value, so also there are functions that do the same thing for integers, floating point numbers or decimals, and booleans. So in this code, the computer runs line 1, creates myInt as string, and gives it the value 5 in quotation marks, indicating that this is represented as text, not as an actual number. On line 2, it converts myInt as string to an integer and assigns the value to myInt. And we see the result is that sure enough, myInt has the type int. The same thing happens on lines 5, 6, and 7. It creates the variable myFloat as string and gives it the value 5.1 in quotation marks, tries to convert it using this float function, and then prints its type. And sure enough, it has the type float. And then on line 9, it creates the variable myBoolean as string, gives it the value true in quotation marks, and then on line 10, uses the bool function to convert it to a boolean and assign the value to myBoolean. On line 11, it prints that variable's type, and sure enough, it's also a boolean. So it works the exact same way, right? Well, there is an added level of complexity here. We said before that nearly everything has a string representation, so we can put pretty much anything into that string conversion function. What would happen if we tried to run that integer conversion function if the variable myInt as string didn't actually store text that represents an integer? For example, what if myInt as string was 5a, for example? Or what if it was David? The result would be a value error that would basically tell us that we can't convert those numbers to integers. We can see that in a kind of trickier context. Here on line 1, we create a variable myInt as string and give it the value 5 in quotation marks. Instead of converting it to an integer, we then try to convert it to a floating point number. So we put myInt as string into our float conversion. And then on line 3, we print out the type of myInt as float. And sure enough, we find out that it's a float. That's a conversion we can do. We can take an integer and interpret it as a floating point number or interpret it as a decimal number. You would basically just assume that you're going to add 0.0 to it. What about the other way around though? On line 5, the computer creates the variable myFloat as string and gives it the value 5.1 in quotation marks, meaning that it's a string. On line 6, it tries to convert it. Specifically, it tries to convert myFloat as string to an integer. And our result is an error. Specifically, it's a value error. We could convert the integer 5 to the floating point number or the decimal number 5.0, and we would consider them equivalent. How can we convert 5.1 though to an integer? An integer is a whole number. That means it can't have any decimals. The only way to convert 5.1 to an integer would be to lose some information, to lose that 0.1. And that's not something Python can do automatically. If we wanted to convert it to the integer 5, we would have to first convert it to a float, then round that float down, and then convert it to an integer. So the general point here is that you'll receive a value error whenever you try to do a type conversion like float or integer on a value that can't actually be converted to that type. For example, we can't convert 5.1 to an integer. We can't convert the string David to a floating point number. We can't convert the string sandwich to a true or false value. If we try to do any of those things, we'll get a value error. Now, I would highly recommend playing around with this because you might find you can do some conversions that you might not expect. For example, can you convert a boolean, a true or false value, to an integer? Can you convert an integer to a boolean? Try it out and see.